Alright, so we're going to use binomial expansion to find the distribution of a net charge over an extended region. Net charge in question we're going to determine ourselves. We've got 3-point charges, all distance a, apart from each other, and we're going to evaluate from some far point x to see its electric field. So the one in the middle is going to be set at 0, and they all have their own point charges. So using this electric field equation, which is Coulomb's constant times the charge over the distance squared, I'm going to find the net by adding these all three together from that distance x. So our first charge is 4 q naught times k, which I'm just going to leave k for this example. Its distance from x is the distance x itself plus an extra distance. Even though it's negative a in position, this extra distance will be a itself. So it'll be x plus a squared minus 8 q naught k over x squared plus 4 q naught k over this distance is just from here to here, so ultimately it'll be x minus a squared. Okay, so I'm going to simplify this to make it easier to work with. I'm going to pull out 4 q naught k from this whole thing. So we're left with 1 x plus a squared minus 2 over x squared plus 1 over x minus a quantity squared. Now, inside of all of these terms, there's an x squared hidden inside. So I'm going to pull them out. And if you need to see it to believe it, go ahead and FOIL it out and find it for yourself. That this will end up looking like 1 plus a over x squared, if you pull out an x squared, minus 2 plus 1 over 1 minus a over x squared. Okay, taking this one step further, I'm going to rewrite this entire thing so that it's easy to work with for evaluating it really far. So this right here is where x is greater than the distance a. This will be where x is much greater than the distance a. So rewriting this to be more familiar to work with for this next part, 4 q naught k over x squared times this whole thing. I'm just going to write as 1 plus a over x negative 2 because it's in the denominator, minus 2 plus 1 minus a over x negative 2. Okay, so binomial expansion is basically a big estimation that is going to tell you how something's going to act whenever you're really far away. So if this is our net electric charge, we're going to use this estimation and we're going to plug it in for these terms right here because it looks very similar. Form is the same. This is just the recipe. So this is our epsilon value, and we'll evaluate both of them separately. So for the first one, we've got 1 plus a over x to the power of negative 2. I'm going to scoot it over because we're going to need the room. Bear with me here. Approximately 1 plus negative 2 times epsilon, which is a over x, plus 1 over 2 factorial times negative 2 times negative 2 minus 1, negative 3, epsilon a over x squared, plus 1 over 3 factorial is 3 times 2 times 1, which is 6, times negative 2 times negative 3 times negative 2 minus negative 2 is negative 4 times epsilon a over x cubed. You can see this follows a pattern. I'm going to stop there. So simplifying this down, we get approximately 1 minus 2a over x. 2 factorial is just 2. 2 times 1. We've got a negative and a negative there. That's going to leave us with a positive. These will cancel, so plus 3 times a over x squared. Over here, we've got a negative, negative, negative. That's going to leave us with a total of negative. 2 times 3 is 6, which will cancel out that division, we've got negative 4 times a over x cubed plus dot dot dot. Okay, this is for our first term. Now I'm going to do it for the second one. And I'm going to leave this here, I'll just jump over it and we're going to add them together. So this will be 1 minus a over x to negative 2, approximately. 1 minus, plus negative 2 epsilon is negative a over x plus 1 over 2 factorial is 2 times negative 2 times negative 3 times negative a over x squared plus 1 over 6, 2 times 2 times 1, times negative 2 times negative 3 times negative 4 times negative a over x. Oh, this one's cubed. Plus dot dot dot. Let's simplify it right here. We've got 1. Negative, negative leads to positive plus 2a over x. Right here we've got negative squared, which is positive, negative, negative, positive also, plus the 2 will cancel, 3 times a over x squared. Over here, negative, 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 negative cubed. So these, it's like negative to the 6th. Negative, negative, negative gives me negative 1. Negative, negative, negative. Here, also negative 1, but these two make a positive, which is kind of like negative 1 to the 6th, which is also positive. 2 times 3 is going to cancel out that division by 6. So plus 4 times a over x cubed plus dot dot dot. Now let's smash these together, all right? These terms are going to cancel, right? Because we're going to plug them back in right there. So we're left with, this is going to add up to 2. So I'm going to go ahead and just plug this in up here. These guys add up to 2. Those guys cancel. These guys add up to a grand total of 6. A over x squared. Those guys cancel. Okay, so this is what it looks like now. Oh, I forgot my minus 2. Sorry. That's from over here. Okay, so then these guys go away, and we're left with what this looks like in total is 24 q naught times k. We've got a squared over x to the 4th. This term right here tells us that we have a quadrupole, which if you try and look at how these point charges behave, I'm going to draw them with their spiky hedgehog features, where negative pulls inwards, positive radiates outwards. In, 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 in. I'm just giving them 8 arrows here. This looks like a hedgehog now. This is radiating outward. Notice how those arrows will correspond with the magnetic or electric pole there. There is a magnetic going on. Okay, all these arrows may be a little bit hard to see on top of all the purple, but this is what they're going to do. This is the motion they follow. And as I continue drawing these arrows, we'll start to see some sort of shape coming together, which is going to have 4 distinct parts. These little quadrants here, which proves that we've got a quadrupole going on right there.